Assalamualaikum warahmatullahi wabarakatuh. Today, our Group 9, will be presenting our mini project called Automated IoT SOS Notification System. So, our group members consist of 3 people, Ariel Lehan Robert, and me, Ahmad Abdul Jalil, and our third member is named Nur Azizi bin Nur Azmi. So, for the introduction, I'm not gonna read it from the slide. So in some cases, individuals who live alone may pass away without anyone knowing, and their condition may only be discovered days later, just like our friend, one of our friends from our class. So this project called the Automated IoT SOS Notification System is designed to help detect such situations early by monitoring daily phone usage activity using IoT technology. The system uses 3 key indicators, or you can say the inputs. The first one is app usage time. The second one is screen on duration, and the third one is battery consumption. So why are we using these 3 inputs? For the first one, app usage time. Imagine if someone was scrolling apps like TikTok or Instagram Reels, and while charging his phone, of course, and lying on his bed probably, and suddenly he or she passed away. The app on the phone may remain active for hours because the phone is still charging. A very high app usage time with no interruptions could be a sign of abnormal behavior, or maybe you can say theft. So the second one is screen on duration. Basically, when a person is no longer interacting with their phone, um, the screen, of course, will stay off. A sudden drop in screen activity may indicate a loss of consciousness, or maybe worse, like death. And the last and third one, battery consumption. A phone that stays unused eventually will run out of battery, 0% battery. If the battery drain is unusually low over time, it means the phone hasn't been touched or charged. Means, example like the phone is dead and the user died, for example, and battery consumption will be 0. There's no battery consumption means that because the person is dead. Yeah. The data is simulated using a publicly available data set. We took it from Kaggle and processed through ThingsBot and IoT dashboard platform. Although this system cannot prevent death, it may help ensure that individuals who live alone are not left unnoticed, allowing loved ones to be alerted sooner and respond with care. So the next one for the objectives. There are 3 objectives. First one is to build an automated IoT SOS notification system that monitors mobile usage using data from from Kaggle. The second one is to alert the user based on predefined thresholds for app usage, screen on time, and battery drain. Those 3 inputs. And the last objective is to create a real-time dashboard in ThingsBot for live data and alerts. And for the methodology, so I'm going to explain step by step. So the first step, we use mobile usage data set from the Kaggle website, and we upload it into the Google Drive. It includes app usage time, screen on duration, and battery for those three inputs, of course. And then Google Colab was used in this mini project to load, clean, and format the first 100 entries to prepare them for IoT integration. So basically, in our mini project, the data that we found on Kaggle has 700 entries. It's too much, so we cut it from 700 to 100 entries. And then the process data was sent from Google Colab to ThingsBot uh, to simulate real-time monitoring using a static dataset. Uh, that part, Area will be explaining it later. And then the ThingsBot will display live charts and value indicators. Um, the value indicators like the user status was shown like three conditions, whether that person is good, still on good condition, or maybe um, that person might be in trouble, or so we send a warning, or maybe he's basically is dead. That's the worst scenario based on set limits. Then the system runs automatically, of course, from data input to status display, showing how IoT and cloud tools work together for smart monitoring. And then for demo, I will pass it to Ariel.
Good evening. So right now I'm going to show you the simple demonstration of our mini project. So as you can see here, this is the Things board that we already set up. And this is our coding. So I'm going to explain the coding first, and then I'm going to explain the output. So the first one is the first section of the coding. So what this coding basically does, it gives access for the Google Colab to access your Google Drive file where you save your CSV file. This is where you save all the data, and this is where it is very crucial for the Google Colab to create the output that you want. And this is the second line. You can see here, there are about 700 data in our CSV file, but we only extract it to the first 100 because it is going to be so much data and we don't want it. And the last one, this is the coding that we use to send our warning and our SOS message. So basically, this is the range of the data. The first one is app usage, second one is screen on time and battery drain. So basically, if the app usage time is more than 180 minutes per day, or screen on time is less than 3 hours, or the battery drain is less than 1000 milliampere, it will give a warning sign. And if it is more than 420 minutes per day for app usage time, or less than 2 hours screen on time, and less than 500 milliamp per hour battery drain, is going to return an SOS time. So you can see. So we're going to run it one by one, and then we're going to see if there's changes in the things board. First one is done, and this is the second one. Now, very quickly, I want you to pay attention to what's going to happen in the things board. Then I already run the code. And as you can see here, this is the code that we run. So we already set the delay to 5 seconds for every new input to come in. And you can see here, this is the exact input that we have in our CSV file. And this is the warning. And the sign, the status of our device. So it's still at warning. And I want you to pay attention to the status right here. So you can make a comparison whether or not this is SOS, whether or not this is warning, or else this is going to be just good status. So there are three different status that we want to pay attention to. As you can see here, um is one of the variables is correct because we are using the or get, I would say, to differentiate all the variables so that we can get our output. So there are going to be 100 outputs for every constituent. So if you want to look at this chart, we're going to have to spend 500 seconds. So I don't want to waste all the time. So let's just go through the result. So this is the result in discussion. So this is the coding that we used earlier. And this is also the coding that we use. And this is the FUSH time. So I want you to pay attention to the status. 28 minutes per day, 6.2 hours a day, 1851 milliampere. So if you were to compare it to the parameter that we already set, why does this give the warning? Well, this gives warning because the app usage time is 398 minutes per day. It doesn't surpass the threshold of 420 minutes per day, but it does surpass the threshold for warning sign. So this is why the warning sign come out. And then this is the SOS because the app specifically detects that the app usage time is more than the threshold that we set, which is 420. Now it is at 462. So the app will give an SOS sign. And that is for the app usage time. This is for battery drain if you want to compare it with warning and SOS threshold. It's pretty simple. 3.6 hours a day. And this is the warning. Battery drain because it is less than 1000 milliamp per day. And if we were to go to the SOS, this is less than the threshold that we set, which is 500. So it is less than 500 at 457. So it triggers the SOS notification. The last one is, no, well, the second last one is screen on time. As you can see, the screen on time here is what? 2.5 hours a day. The threshold that we set for warning is 3 hours. So it is less than 3 hours, so it is a warning sign. And for the SOS, we set it to less than 2 hours, and it is 1.4 hours a day right here. So it sends us the SOS notification. And if none of the warning or SOS notification SOS notification threshold was satisfied, if it will go to else statement and it will give this output, which is good. So it is normal, nothing to worry about. Yeah, that's it for my short demonstration. And I want to quickly explain why we set the threshold of warning and SOS in a certain way. So the app usage time, if app usage time is more than 180, it will trigger warning, and more than 420, it will trigger SOS. Why we made this happen is because if you were to be on your phone for a very long time, what it basically means is you are either alive or not. But if you're not alive and your phone is on for 420 minutes a day, that basically means there are no one to uh, switch off your phone. So that's basically what it means. And the screen time, if it is less than 2 hours a day, we can hypothesize that you are dead because for every 24 hours, this clock will refresh. And if it detects you are doing less than 2 hours a day, that basically means that you don't spend a lot of time on your phone, which is crazy these days because everybody is on their phone. And the last one is battery drain. If your battery drain is less than 500 milliamp each day, what this basically means is that you don't use your phone and your battery drain and you don't go and charge your phone. So that's why we set the threshold the way we set it. And that is why our app is so sophisticated. We'll send the warning first, and then if the user did not reset the warning, it will just go to the SOS. So yeah, that's it. And that is all for the explanation and our short demo for our mini project. Thank you.
So I'm back again for the conclusion. So in conclusion, this project has been successfully achieved all its goals, just like all the other mini projects that we have done. And an IoT based system was built to monitor mobile device usage by analyzing three key indicators or three inputs: app usage time, screen on duration, and battery drain. A data from Kaggle was also has been used to simulate real user behavior, and the data was processed in Google Colab before being sent to ThinkSpot from the app. The system automatically classifies user status into three conditions: in good condition, and sending warning, or in the worst case scenario, SOS, based on set thresholds. Uh, a real-time dashboard was also created in ThinkSpot to display the data or the input using live charts and indicators, making it easy to monitor the user's condition without any with, without any manual input. And that's all from us. Group 9. Thank you very much for listening.